So here we have a network of resistances, and we need to find the total resistance between these 2 points. So we need to combine all these resistors together into a single resistor. So we're trying to find patterns of series and parallel resistors. So if you look at these 2 resistors, although they're connected at this point, they're not in series because there's a branch here. That means the current passing through this resistor is not the same as the current passing through this resistor because we have a current going here. The same with these 2. They're not in series because we have this branch here. Now these 2, they look like they're in parallel, but they're not in parallel because they're not connected from this side. And they're also not connected from this side. So we can't use these 2. But if you look at these 2, it looks like they're connected from one side and they're connected from the other side. So these 2 are parallel. So we can combine these 2 into a single resistance. So we can say the parallel equivalent will be 1 over 6 plus 1 over 9 reciprocal. So that will give you 3.6 ohms. So I can replace these 2 with a single 3.6 ohm resistor. And I can connect that resistor between these 2 points. So my new circuit will look like this, where I've got 3.6 here. So this is the equivalent of those 2 parallel resistors. Now you notice that this resistor and this resistor look like they're in series because the current passing through this is the same as the current passing through that. They're connected through one point and there's no branch. So these 2 are connected in series. So we can simply say that the total series resistance is the sum of 2.4 plus 3.6. So that'll give you 6 ohms. So now we have the total of these 2. We can replace these 2 with a single resistor between this point and this point. So we can combine these 2 into a single resistor, and it'll look something like this, where this 6 ohm equivalent resistance is right there. So that's my 6. Now, if you look at this resistor and this resistor, they're connected from one end and they're connected from the other side. So these 2 are parallel. And you can find the equivalent of these 2 by saying 1 over 6 plus 1 over 5 to the power minus 1. Okay, and that will give you 2.73. So now I'm going to replace these 2 with a single resistor connected between this point and this point of 2.73 ohms. So my new circuit will look like this, and my 2.73 is right there. So this is my 2.73 ohms. Now the circuit's much simpler because you have these 3 resistances in series. Why do we say they're in series? It's because it's the same current passing through each of the resistances. Or you can say that each 2 are connected with a single point with no branches. That's a single branch, a single point, but there's no branch. So it's the same current passing through them. So it's a series resistance. So I can say that the total resistance is now 5 plus 2.73 plus 5. That looks like it's going to be 12.73 ohms. So my final circuit will look like that. My 12.73 is right there. Okay, so that's not allowing me to do that. So that's 12.73 ohms. And that's your final answer. So now you've reduced the circuit to that. You can find the current very easily. You can say the current is simply 15 over 12.73. You divide the EMF divided by the total resistance. So that's how you would reduce a network of series and parallel resistances.